This video is on systems of equations and inequalities, specifically focused on quadratics. We're going to be dealing with quadratics and linears together. First one we're going to talk about is systems of equations. The equations and inequalities will be different. Inequalities is when you shade. Equations is when you just find the solution or solutions. When we're dealing with the linear and a quadratics, we're going to have a line and a parabola. We could have different types of solutions. We could have a graph that has 0 solutions, graphs that have 1 solution, and graphs that have 2 solutions. An example of a system of equations of linear and quadratic that have 0 solutions is, I'm just going to draw a basic parabola. I'm going to draw a basic parabola. I'm not worrying about my coordinates right now. I'm just worrying about making sure I have a parabola. And then I also need a line. So I want to make sure that these never cross. So my line, I'm just going to draw a line like this to show that these two will never cross each other. This is no solution because they never cross. There's no point of intersection. To have one solution, there's a couple of ways to have one solution. I'm going to draw my basic parabola again. Now, one solution, you can have a vertical line going through the parabola to make one solution. However, a lot of times you'll see parabolas that will have a line that will just touch the parabola. So I'm going to show that one on here. My example will have a line that is barely touching the parabola. So it's just touching that parabola. So the solution for this one would be where the parabola and the line touch each other, which is about right in that location. And that would be an xy coordinate. For two solutions, we'll have, again, a basic parabola. And the line needs to make sure that it goes through twice. It can go through very careful, like very small here, where you have a solution here and then here. I want to make sure I show the solutions on here for an example very clearly. So here I have a line, the pink line and the blue parabola crossing twice. These are the two solutions for a parabola and a line. A parabola and a line cannot cross 3 times because it would no longer be a parabola. And the line, because it can't come back around, it wouldn't be a line if it came back around. Now we'll also be dealing with quadratic. So instead of just quadratic and linear, we'll have 2 parabolas. For 2 parabolas, you can have 0 solution, 1 solution, 2 solutions, and infinitely many solutions. A 0 solution is when your 2 parabolas will not intersect at all. So a basic one here would be a parabola that's opening up, and then a parabola that's opening down, that do not cross. So these have no solution. A 1 solution could be 2 parabolas that just touch on the vertex, kind of like how I have it here, where the line's just touching it. But there is another way that parabolas could have just 1 solution. It's a little tricky. So I'm going to have my first parabola like this. My second parabola, however, it's going to go through this first parabola, but it'll cross just once, and it's because of how wide it is. So this blue one right here, it'll keep going up and to the right. So will the pink, but because of the pink one, it will never go close enough. It's not going to be too wide to where it'll end up hitting the blue again. And this one, same thing. The blue will keep going up, but the pink will keep going up and to the left as well, but they'll be too far apart to be able to hit again. You got to be careful about these kinds because it depends on the width of it to see if they could ever cross again. So it is very important that we're careful on drawing this example. 2 solutions is, a lot of times you'll see this when you have a parabola opening up and a parabola opening down, but this time they will actually cross. My first parabola is opening up, and then I'll have a parabola opening down, but it just needs to cross through it twice. So we can see that we have two intersections, so that's why we have two solutions. And again, this is just the way that the graphs could potentially look. This is just an example. Infinitely many goes back to if you have the same types of words, so quadratic, quadratic, linear, linear, any type of function that's the same type of function, you can have infinitely many, because infinitely many is when the graphs are the exact same. So if I have a parabola, my first parabola looks like this, and if my second parabola happens to be the exact same, so it will literally go right on top of it, then this would be infinitely many solutions because they are the exact same. Now, not every coordinate is a solution. Please remember that is not what infinitely many means. Infinitely many means that there are an infinite amount of points on the parabola that is a solution. These are the types of graphs or types of solutions you can have for linear quadratic and also quadratic quadratic. These are just types. These are not the only way that they can look, but it's a good representation of how will it look.